Alright, in this next video we're going to take a look at how to use solubility curves to answer basic questions in the solutions unit for grade 11 chemistry. This is similar to some things that we did in grade 9 advanced science if you were in the advanced program back in grade 9. So a solubility curve is just a graph that shows you how the solubility of different substances is affected by temperature. So on the x-axis we have temperature from 0 degrees Celsius up to 100 degrees Celsius. On the y-axis we have solubility, and it says here grams of solute, so the grams of each chemical, per 100 grams of water. Okay, now the density of water is 1 gram for every milliliter. So when it says 100 grams of water, that's the same as 100 milliliters of water. So we can think of the solubility as being either grams of solute for every 100 grams of water, or we can think of it as grams of solute for every 100 milliliters of water. Those are going to be the same numbers. Now we notice that, first of all, most of these graphs are going up. Okay, they're almost all going up. There's a couple that are dropping. For ionic compounds, for solid substances, their solubilities typically increase when you raise the temperature. Okay, that's not always true. Here's a cerium sulfate salt, which is lowering its solubility as you raise the temperature. Whether the solubility increases or decreases is really a function of whether the dissolving process is exothermic or endothermic, and that's a little bit beyond grade 11 chemistry. But just realize that most substances will increase in solubility when you raise the temperature if they're solid. Ammonia, NH3, is a gas, and gases do the opposite. So for gases, as you raise the temperature, their solubilities typically drop. And I don't think there's any exceptions to that. So for gases, when you get hotter and hotter water, the solubility gets lower and lower. But for salts, the solubilities increase typically. Okay, there's a few exceptions to that, but typically that's the pattern that follows. So the first thing we want to do is just read the graph. Okay, so question number 1. What is the solubility in grams per 100 milliliters of water for each of the salts below? Okay, so ammonium chloride at 40 degrees Celsius. So I'm going to find 40 degrees Celsius, here we are, and ammonium chloride. Where's ammonium chloride? Well, that's this line here. There's a label there that says NH4Cl. So 40 degrees, I go up until I hit that line, so this point right there, and then I'm going to estimate the solubility. And I see that it's between 40 and 50, and I think it's slightly closer to 50. So between 40 and 50, but closer to 50, I'll say 46 grams for every 100 milliliters of water is my solubility. All right? Now you notice that that looks like a unit multiplier. 46 grams of ammonium chloride for every 100 milliliters of water. And we're going to use it like that in just a few minutes. Second one says potassium chlorate at 93 degrees Celsius. So 93 degrees Celsius, 90 and 100, 93 is going to be slightly less than halfway. Potassium chlorate is this curve here. It's this curve here. Got to be careful. All right. So I want 93 degrees Celsius. That's going to be approximately that point there on the potassium chlorate curve. So now we go over to the y-axis and we see it's between 50 and 60. It's slightly closer to 50. So I'm going to say the solubility is 54 grams for every 100 milliliters of water. Okay, and again, you could be saying grams of water if you prefer. The density of water is 1, so grams and milliliters are going to give you the same number. Cerium sulfate at 0 degrees Celsius. So cerium sulfate is that one exception to the solids that's dropping, and 0 degrees Celsius is ice water, so it'll be over here. Now you might be thinking, well, wouldn't it be frozen if it were 0 degrees Celsius? Pure water would be frozen, but when you dissolve salts in water, the freezing point of the solution will be lower than the freezing point of pure water. So at 0 degrees, you can have a solution of salt. So we're looking at this point right there on the cerium sulfate curve. It's between 20 and 30. It's closer to 30. Probably about 27 would be a good estimate. 27 grams for every 100 mils water. All right? So I'm not going to do all of those, but you get the idea. You're able to read the graph. So the question number 2 says, which compound on the chart is covalent instead of ionic? Ionic is where you have a metal cation bonded with non-metal anions, or where you see complex ions involved in the formula. The one that does not fall into that category is ammonia, NH3. So NH3 is ammonia. Ammonia is covalent because it's made of only non-metals, and there's no ions involved in that formula. They're sharing electrons, they didn't transfer their electrons. And we said that ammonia was a gas at room temperature, so why don't we say ammonia gas? And it's a gas at all of these temperatures, and when it dissolves in water, its solubility drops. Okay? So what does it mean for a solution to be saturated? What does it mean for it to be supersaturated? To be saturated simply means you have the concentration of the solution is equal to the solubility of the salt, okay, or of the solute. Another way to say that is if it's saturated, you cannot dissolve any more solute. So you've reached the maximum possible concentration when a solution is saturated. Now, having said that, it is possible sometimes to get a solution to have more salt dissolved than you thought it could. So you might heat it up to a very high temperature where the solubility is greater, and then slowly cool it down. The solubility should fall lower and lower, but you might be able to have a solution where, because you started with more salt dissolved at a higher temperature, as you cool it down, some of that salt that should no longer be dissolved stays dissolved. And so what you have is called a supersaturated solution. Supersaturated simply means beyond saturated, above saturated. So you've somehow got a solution with more solute dissolved than should be. It's highly unstable, and if you simply stir the solution or reach in and scratch the glass inside the beaker or inside the jar, the excess salt that wasn't supposed to dissolve will precipitate. So it really wants to precipitate and become saturated because it has too much salt dissolved. And now we're going to get to some mathematical problem solving using unit multipliers. A solution is made by dissolving 175 grams of ammonium chloride in 250 mils of water at 70 degrees Celsius. We're going to calculate the concentration and then determine whether the solution is unsaturated, saturated, or supersaturated. So the simplest way to do this, there's several ways to do this, but what I like to do is just calculate the concentration of your solution. So the concentration of the solution, we're not going to use molarity for this. We're going to use the same concentrations that are up here on the graph. So mass of solute for every 100 mils of water means that we can come up with a little formula. The concentration is the mass of the solute divided by the volume of the water times 100. Okay? The mass of solute will be in grams. The volume of water will be in milliliters. If we just divided those two things, we would have grams of solute per milliliter of water. But to get the 100 mils of water that's up in the graph, we're going to times by 100. So then instead of per milliliter, it'll be per 100 milliliters of water. So this concentration is 175 grams divided by 250 milliliters of water and times by 100. So 175 divided by 250 times 100. The concentration is 70 grams for every 100 mils of water. Now, how can that tell me whether the solution is unsaturated, saturated, or supersaturated? The temperature was 70 degrees, and we're talking about ammonium chloride. So I'm going to go up to my graph and look at the solubility. So 70 degrees Celsius, the ammonium chloride curve is here. So at 70 degrees Celsius, the solubility, the maximum possible concentration that you're supposed to have, is a little bit more than 60. So probably 61 or 62. So I'll say here at 70 degrees Celsius, the solubility of NH4Cl is 62 grams for every 100 mils water. And you remember that the solubility is supposed to be the maximum concentration that you can have to have a stable solution. But our solution's concentration is 70 grams per 100 mils. So we've somehow got more salt dissolved than we were supposed to. 62 would be saturated. That's our solubility. We have more than what would be needed to saturate it. So therefore, because our concentration is bigger than our solubility, so since the concentration is bigger than the solubility, the solution is supersaturated. Okay? Number 5, the same idea, so I'll leave you to do that on your own. It says boiling water, which of course means 100 degrees Celsius. 2 liters, you'll have to switch that to milliliters, 2,000 milliliters, and you'll do exactly what we did. You'll calculate your concentration, you'll look at the solubility of sodium chloride at 100 degrees Celsius. If your concentration is greater than your solubility, you have a supersaturated solution. If your concentration were equal to your solubility, you'd have a perfectly saturated solution. And if your concentration was less than your solubility, you'd have an unsaturated solution. All right, now let's do some unit multiplier calculations. What mass of potassium chlorate can dissolve in 25 mils of water at 20 degrees Celsius? So the first thing I want to do is take a look at my solubility chart for potassium chlorate at 20 degrees Celsius, and I need to look up the solubility. So 20 degrees Celsius, potassium chlorate, it's this point right here. It's maybe slightly less, but I think it's very close. I'm going to say 10 grams for every 100 milliliters. So the solubility, so at 20 degrees Celsius, the solubility of the potassium chlorate, solubility is 10 grams for every 100 mils of water. And remember, that's a unit multiplier. So we have 25 mils of water, and we want to know what mass can dissolve. So take your volume, 25 mils of water, and with 1 unit multiplier, switch from mils of water to grams of our potassium chlorate. And the solubility told me 10 grams for every 100 mils of water. And so that means we can dissolve 2.5 grams of potassium chlorate in that water. Okay? That's not that hard. Let's go down to number 8. What mass of sodium nitrate can dissolve in 2 liters of ice water? So 2 liters of ice water, sodium nitrate. So I look up at the sodium nitrate curve. Ice water would be at 0 degrees Celsius, so we're talking about this point right there, slightly less than halfway between 70 and 80, so probably 74 grams per 100 mils. So at 0 degrees Celsius, the solubility is 74 grams for every 100 mils of water. Now there's some estimation involved in reading the graph, So if you read the graph a little bit different, maybe you said 75 or 73, you'll get a slightly different answer than me, but your answer will be acceptable on a test or exam. So now, we have 2 liters of water, but our solubility doesn't have liters, it's got milliliters. So the first thing I'll do is switch those liters to milliliters. And now, using the solubility, we can get rid of the milliliters of water and switch to the grams of the sodium nitrate and get our answer. So there's 1,000 milliliters per liter. 74 grams for every 100 milliliters is the solubility. So 2 times 1,000, 2 times 1,000 times 74 divided by 100 equals 1,480, but I can only keep 2 significant digits, so I'll call that 1,500, or using scientific notation, 1.5 times 10 to the 3 grams of sodium nitrate can dissolve. All right. Question number 9 just reverses that slightly. A student wants to dissolve 225 grams of the cerium sulfate at 25 degrees. What volume of water will she need to make a saturated solution? So we're going to do exactly the same thing, but this time we're going to find the volume of water. So at 25 degrees Celsius, we look on our chart for cerium sulfate. This curve here at 25 degrees, we're talking about that point, which is slightly higher between 10 and 20. So probably about 17 or maybe 18. I'll say 17. So the solubility is 17 grams for every 100 mils of water. We have 225 grams. So 225 grams, and we're going to ask what volume of water does she need. So switch your grams to milliliters of water, and our solubility told us 17 grams for every 100 mils of water. So now 225 times 100 and divided by 17, she needs 1,323, but we can only keep 2 significant digits, so we'll say 1,300 milliliters of water. She needs about 1.3 liters of water to dissolve that salt. All right, there's one last type of question on this worksheet, questions 11 and 12. Number 11, a student has added 75 grams of sodium nitrate to 50 mils of water at room temperature. Notice it says they added it. It doesn't say it dissolved. So you have 50 mils of water in a beaker, and you've just dumped in 75 grams of sodium nitrate. It doesn't all dissolve. You can look at the solubility and compare it, and you'll see that the solution, it just won't all dissolve. So to what temperature should the solution be heated to make sure that all that salt does dissolve? So what I'm going to do is first calculate the concentration of the solution if it were to dissolve. So if it dissolves, the concentration would be the mass of the solute divided by the volume of the water times 100. So it would be 75.0 grams divided by 50.0 milliliters times 100. That's going to be 150, I think. 75 divided by 50 times 100 is 150 grams for every 100 mils. So if the salt were to dissolve, that would be the concentration. So this is sodium nitrate, and I'm wondering to what temperature should I heat it? It's starting off at room temperature to make sure that it all dissolves. So what I'm going to do is find 150, the concentration that we just calculated. I'm going to find that number on the y-axis. if our salt just perfectly dissolves, then it will be saturated, and the concentration will equal the solubility of the salt. So 150, the concentration of our solution, is way up here at the top of the graph. And we're talking about sodium nitrate, which is this curve over here. So what I'm going to do is just go on my graph right over from 150 until I hit the sodium nitrate curve. There we go. Then I'm going to go down to the x-axis and see, well, what temperature would the solubility be 150? And that temperature, if you come straight down, is about 80 degrees Celsius. So in my answer over here, I'll just sketch what we just did. So temperature, solubility, and we found 150 on the y-axis, and there was our sodium nitrate curve. That was the sodium nitrate graph. Oops, I just realized you can't see that. And so 150 will go straight over until we hit the sodium nitrate curve, and then we went right down to see what temperature that would be, and that was 80 degrees Celsius. So therefore, 80 degrees Celsius is the temperature to which we should heat the solution, so that its concentration of 150 would be the same as the solubility, and that means the salt would dissolve at 80 degrees Celsius. Okay, do the same thing for this last one. You've put 200 grams of ammonium chloride in 350 mils of water at room temperature. It doesn't all dissolve. So you're going to heat up the water to make it dissolve. To what temperature should you heat the water to make sure it all dissolves? So it's the same question we just did. So if it were to dissolve, the concentration would equal, same formula, so I won't write it again, it's going to equal 200 grams, the mass of the solute, divided by 350 milliliters, the volume of the water, and times by 100, so that we can say per 100 mils of water. So 200 divided by 350 times 100, this is going to be 57.1 grams for every 100 mils. Now we're talking about ammonium chloride this time, and so I look at my graph, and we're going to do the same thing. So temperature on the x-axis, solubility on the y-axis, and the ammonium chloride curve looks something like this on our graph, like that, and we're going to find 57 on the y-axis, the solubility, and we're going to go over to our graph, and then we're going to go straight down to the temperature axis, and we're going to see what temperature that is, so that the solubility is the same as our concentration. So let's take a look at the graph. 57 would be approximately here, and the ammonium chloride curve is this one over here. So going straight over to the ammonium chloride curve, and then straight down, we're between 60 and 70. It's pretty much halfway, maybe slightly less. So 64 or 65 degrees Celsius would be a good answer to this question. So I'll say 65 degrees Celsius, and that's the temperature to which you should heat the solution so that all of our salt would dissolve. And when it dissolves, the concentration will be the same as the solubility. The solution would be perfectly saturated at that temperature. Alright, so there's a variety of questions involving solubility curves, ranging from just reading the graph, calculating concentrations to identify whether a solution is saturated, supersaturated, or unsaturated, using unit multipliers to calculate volume or mass of salt or of water or salt, and finally at what temperature would a salt completely dissolve in water.